Okay, so example 1, part A. We've got f of x, which is x squared plus 7x plus 12. G of x, which is x squared plus 5x plus 6. And so part A just says f plus g, so we're just going to add them, that's all. So I'm going to go, all right, I'll take my x squared plus 7x plus 12, and I'm just going to add in my x squared plus 5x plus 6. And then just combine like terms. I'll have a 2x squared plus a 12x plus 18. That's it.
Wow, look how perfectly you connected the line. Look how
Easy.
perfectly you connected the circle.
Wow, okay.
That's really crazy.
That is crazy. Okay, B. B says just to subtract them, right? So I'll take f, which is x squared plus 7x plus 12. Now, when I subtract, I'm going to do a little bit differently. I'm going to be careful to bring through the negative, okay? So subtract my x squared plus 5x plus 6, okay? So I use parentheses to show that I'm subtracting all of g of x, not just x squared, right? That's why the parentheses are important. Yes, Simon?
Wait, can't you just flip all the signs in the parentheses and make it a plus?
There you go. Watch this. So Simon remembers this. This is a cool little trick because sometimes you got to be careful of double negatives. So what you can do is bring the negative through. Totally agree. So Simon says, why don't I just do this and make it a minus x squared, a minus 5x, and a minus 6. And that's handy because sometimes there's a negative in here and you forget to make the negative with a negative positive. But I like that little trick, Simon. Thank you. That helps me a lot. So then x squares will cancel, right? And then I'll have a 7x and a negative 5x makes a 2x, and a 12 and a minus 6 makes a positive 6. Good job, Simon.
What?
Okay, what do you think? C. What do you think C says? Multiply. Yeah, multiply. Now this is going to be kind of a pain, but we'll multiply it. X squared plus 7x plus 12. That's a 12. It's a bad looking 12, but it is 12. X squared plus 5x plus 6. Okay, so it's a superfoil. You ready for a superfoil? Alright. Or it's super distribute, but we're going to multiply. So, you ready? Here we go. X squared times x squared is x to the 4th. X squared times 5x is a positive 5x cubed, right?
Oh, I remember.
X squared times 6 is a positive 6x squared. Now, here's the way I do it. And you guys don't have to, you can keep going all the way across. But I'm now going to go 7x times x squared. I'm going to put it right here because it's a 7. It's a positive 7x cubed. See how I line them up? I line them up because when it comes time to add them, they're with each other, right?
Wow.
And I'll go as 7x times a 5x makes a 35x squared, so I'll put it right here. And then I'll go 7x times 6 makes a positive 42x. Okay, and then when I do the next one, again, I'll line them up. I'll get a 12x squared. So I'll put a positive 12x squared here. I'll get a positive 60x. And then I'll get a positive 72. And when I do this, the reason I like to do this is because then when I come to adding them, things are lined up. That makes sense. And then I've got my x to the 4th comes straight down. I can add my x cubes, I can add my x squareds, I can add my x's, and then I can bring down my 72. That's the way I like to do it, so things are lined up. X cubes, x squareds, x's. Okay. So I bring down the x to the 4th plus a 12x cubed. Oh, I don't know. Calculators, that's what they were invented for. What's 6 plus 35 plus 12? 53 x squared. What's that? 102 plus 102x plus 72. Okay, that's a set plus 72. Doesn't look like it. There we go. All right, how's that?
Good.
Okay.
Wait, what's that? Is that like
Oh, 102.
That's 102. Yeah.
ZX?
Yeah. Yeah. My z's I will always put a cross through. Always. That's the way I do it, just so you know it's a z, not a 2, okay?
Will you please never use t's as exponents? Because
Yeah,
they look like
they look like
pluses,
pluses.
and it's really annoying.
Well, that's why I write my t's with little tails, right? The book likes t's for time.
I don't like t's.
I'm sorry. I'm sorry. Okay, now, D, F divided by g of x, what does that mean? Divide them. So I'm going to take my f, which is my x squared, plus my 7x, plus my 12, and divide it by my x squared, plus my 5x, plus 6. Okay, now, with division, gosh, in this case, if I can factor, something might cancel, right? So let's see if we remember how to factor. So I'm going to go 2 sets of parentheses, right, to factor the top. So we're going to factor the numerator. So what are the multiples of 12 that add up to 7?
5 and 2, 5.
Try again.
Wait, add to
Multiples of
20.
12. There we go.
5 and dose.
How about x plus 3, x plus 4? Okay, that sounds like a good idea. And what about the denominator? What are the multiples of 6? There you go. X plus 3, x plus 2. Hopefully you guys see that we can cancel the x plus 3's. And so my answer is just going to be an x plus 4 over an x plus 2. Right? Pretty easy? There, I missed it for you. All right, now. You guys ready for example 3? Now this is a composite function. In fact, if you look at it, on A, 3 goes into G. 3 goes into G. Okay, so I'm going to put 3 into the G function. And then that goes into F. So I'll say it again. I'm going to put 3 into the G function, so I'll put 3 into here. Then I'll take that answer and put it in the F. So I'm going to do this. First of all, G of 3 is equal to 3 squared plus 3, okay? So I just stuck the 3 right into there, okay? So that makes a 9 plus 3, which is a 12, okay? So then G of 3 is equal to 12, okay? 9 plus 3, 12. Now what I do with that answer is I take the G of 3, which is 12, and I take the 12 and plug it into F. So I'm going to go then F of 12, which is just simply going to be a square root of 12 plus 1, which is the square root of 13. Okay, one more time. The question says, so you work from the inside out. So I'm going to take 3 and plug it into G. I plugged 3 into G, 3 squared plus 3, made 12. Then I took that answer, the answer of G of 3, and I plugged it into 12, into F. So I took the 12, put it in the F, into the X. 12 plus 1 is 13, square root of 13. Okay? How about B? Yep. Yep, let's plug 8 into H. We get 4. And then we take 4 and plug it into G. I said it, now I'm going to show it. So I take 8 and plug it into H. So I get H is going to be 8 over 2, which is 4. Take 4 and plug it into G. I'll go 4 squared plus 4. Okay, so let's do that. So first of all, H of 8 is going to equal 8 over 2. So H of 8 is 4. So I just took my 8 and plugged it in there. All right, now take your answer, your H of 8, and plug that 4 into G, right? So I'm going to go G of 4 now. And that's going to be a 4 squared plus 4. 16 plus 4 is 20, right? Okay, capiche? It's not too hard, is it? Okay, now C. Oh, we got to do it 3 times, right?
You work from the inside out, right?
Always, yes. Simon's totally right. I'm going to put that on the recording. Simon said work from the inside out. There. Okay? Simon says. I know. So put 16 into H, right? So you'd get 16 over 2 is 8. Take 8 and plug it into F. So I'd get 8 plus 1 is 9. Square root of 9 is 3. Take 3 and plug it into G. 3 squared is 9 plus 3 is
12.
Good. So the answer is 12, right? Let's just do it. Okay. So first let's put G into H. So I'm going to go H of 16 is 16 over 2, which is 8, right? take 8 and plug it into f. So we're going to go f of 8. So 8 goes here. Square root of 8 plus 1, which is square root of 9, which is 3, right? Then take 3 and plug it into g. So it goes right in here. So g of 3, which is equal to 3 squared plus 3. 9 plus 3 is 12. And we were able to do it in our head, right? But it's good to show the work. I mean, but nice job on doing it in your head, okay? All right, turn the page. Everybody good? Okay, I'll wait for you. Not too bad?
Uh-oh, we're doing the fog thing.
Now,
The fog thing is Thank you.
okay, so, now on A,
What's done?
it's saying the same thing as f of g of x, okay? This statement here, the fog, this statement right here means this, okay? They mean the same thing. F of g of x means the same thing of, with our parentheses, the exact same statement, just written differently, that's all. So we're going to take g of x. But we take the entire g of x because there's no numbers in this. So I take the entire g of x, I'm going to plug it into f, okay? So I'm going to plug this whole thing and plug it into there. All right? So I'm going to go ahead and write then 2 times the square root of x plus 3 squared. So I took the entire g function, the whole thing, the square root of x plus 3, and I plugged it into the f. Now you plug it into the x, right? So 2x squared is 2 times.
What?
So this g of x went into f, and it goes in for the x. So you take the entire function, the entire square root of x plus 3, and plug it into x.
And now that's what the little O means?
Right. So it's the exact same thing as we just did. The difference is that it's just written differently, okay? So this symbol here means the same thing as that. So then if I simplify, the square and the square root cancels, right? I'd be left with a 2 times an x plus 3, right? Because the squares cancel the square root. And that'd be the same thing as a 2x plus 6, okay?
Okay.
All right? Now, B,
So now you take
just the opposite, right?
F and put it into G.
Right. So this says the same thing as g of f of x. So Simon said to put the f function, that's all, this is a 2x squared, right? And we're going to put it into the g. So it's going to go right into the g of x. So take the 2x squared and put it into the g. All right? That is going to be a square root of 2x squared plus 3. Now you can't simplify it. That's it. So I took my 2x squared and plugged it into the x of my g of x. So I'm done.
So can you not take the square root of a number with exponents?
Well, you can, but then the problem is that you've got to take the square root of both of them, and you can't. Great example.
So if the 3 was 9.
You still couldn't do it.
You sure?
Yeah, right. So what's that answer? Square root of
Well, you have to
4 plus 9.
5?
Is it? Is it 5 or is it the square root of 13?
Wait, what?
Yeah,
Is
you have
this
to-
is this
order of
the
operations.
square root of 13 or is this the square root
No,
of?
but look, the square
or
root
is
of
it-
4
or is it
2, and
5?
the square root of 9
What do you think it is?
So it's 5. No, wait. Parentheses, exponents, multiply, divide,
It's got to be.
add, subtract.
It's got to be that. Right.
What?
Right. So it has to do with order of operations. So you can't. You have to leave this the way it is. Okay. Then the last one, C, basically says just what it is. It's the f of h of x. Okay. It's a little smushed from the Calc machine, but so we're going to take my h, which is my x over 4, and we're going to put it into my f function. So hold on, let me erase a little bit. So I'm going to take this x over 4 and plug it into the x squared, right? So we're going to write it as 2 times my x over 4 squared. I just took my x over 4 and put it into my f function, right? So that just makes it 2 times an x squared over 16. That's like a 2 over 1. It's like a 2 over 1, which is going to make an x squared over 8. All right. Last but not least. Now, if you don't have the functions, you just have a funny looking graph, what we can still do is we can still like work it out even without having anything to plug in. So let's see what the first question says. Find f of -1 plus g of -1. So what I'm going to do is I'm going to go to -1. Okay, -1, because I got 1, 2, 3, 4, 5, you know, -1, -2, blah, 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 you know, on a number line, right? So here's my x, that's an x value, at -1. So what's the, if this is f, what's the value at -1 of the f function?
0.
It is 0. What is at -1 the value at -1 of g? 2. So what is f of -1 plus g of -1? 2. So I found the x value on the x-axis, and the corresponding y value would be the answer. I'll say it again. I found the x value on the x-axis, and it then said, okay, well here I'm at -1. What's the corresponding y value? One is 0, and the other y value is 2. Okay. Now, how do you add them? How do you add this graph plus this graph? We're just going to add their heights. So what I'm going to do is start from -1. I can't really start from -2 because remember we talked about the domain, they have to overlap. So I can't do -2 because I've got a value for f at -2, but I don't have a value for g. So let's start at -1. We'll go 0, 1, 2, 3, 4, 5. Okay, I'm adding heights. So let's do it step by step. So if I go to -1, everybody's got to pay attention. I'll go slowly, okay? At -1, what's the height of my f function?
0.
What's the height of my g? 0 plus 2 is what? So put a dot at 2. Does that make sense? Okay, go to 0. What is the height of my f function?
1.
What's the height of my g function? 1 plus 2 is?
3.
So we put a dot at 3. See how we did this? Okay, go to 1. What's the height of my f function?
3.
What's the height of my g function?
0.
0 plus 3 is?
3.
There you go. See how easy this is? Okay, go to my value of 2. What is the height or the y value of my f function?
-2.
2. And then my g is?
-1.
2 minus 1 is?
1.
There you go. Piece of cake, huh? Alright, let's go to 3. It's a little hard on 3 to figure out. It looks like it's about a 1.5 and a -1/2, right?
You put it on 2.
Yeah, you put on 2. What?
It's supposed to be it's supposed to be 1.
Oh, I made a mistake. That never happens, does it? You even caught me on film making a mistake. Uh-oh, I'm in trouble now.
Got him.
And I didn't make that mistake.
Alright, there you go. Good.
Probably didn't.
Okay, let's go back to 3. So it looks like about 1.5 and -1/2. So add them together, I get 1, right? At 4, I've got 1 plus 1 is?
1.
1 plus 1 is? 2. There we go, it's all good. And then at 5, I've got a height of 0 and a height of 2.
So it's
2, yeah. So what it would look like is something like this, wouldn't it? And that would be the graph of f plus
Looks
g.
like a really comfy chair.
So homework. Here it is. Let me go ahead and stop the recording.